Okay. Wait, can we see my screen? Can we see my screen again?
Yeah.
I can't.
You can't, Nikki?
No,
Sure.
I can.
Oh, okay. Sorry. Open conversation. So like I said, look, the recording of what we just did is now going to be broken up into two parts. So unfortunately, there's the first bit that we just spoke about. And then I started recording again. And then from where we're going to start now, you'll get the second recording here. But as you can see, it does say recordings are only available for 30 days. So what I would do is I'll press this button and then save it. So you can keep that until next year, even if you needed it. Okay, we are recording, right? It's just, yeah. Good, okay. Let's get back to this. So, where were we? Cos 330. What do you get?
I got root 3 over 2.
Correct. And tan 330?
Negative 1 over root 3.
Negative 1 over root 3. Perfect. Natalia, let's do the next one. Natalia V, let's do G together so you can learn this. Do you have your calculator with you?
Yeah.
Yep, all right, here we go. Sine 225.
Yeah.
What do you see?
Sorry, give me 1 second.
Okay.
Is that negative 0.7?
Yep, so then what we've got to do now, we've got to square that,
Yeah.
which becomes half. Press the SD button. Can you see it becomes half?
Yeah.
Now, you can't go ahead and square it, so you've got to go back and square root it. But you don't use your calculator to root it. What you do, you just square root 1 over 2 yourself. So square root of 1 is 1, square root of 2 is 2. And then, because the original question had a negative, we still have to have a negative here. So the answer is negative 1 over root 2.
Yeah.
Let's do it again. Cos 225. Well, that looks like the same answer, doesn't it?
Yeah.
So what's the answer?
It'll be negative 1 over root 2.
Yep, and then tan 225.
It'll be 1.
Just 1. There's nothing to do with that one. Good. The first bits that you missed, like I said, will just come into your chat. Just go ahead and watch that.
No.
If you want to review it. Okay. Value. All right. Let's do question 3, you guys. Find the exact value of x in each diagram. So, whose turn was it? Larson. Let's do question 3A together. What must you use to solve this? Well, opposite over hypotenuse. Do you remember what trig ratio that was? Larson, are you there? Can't hear you. You got to speak a little bit louder. Go ahead. No, I can't hear you. You're too far away from the mic.
It's good.
No.
Close.
No, can't hear you. Can anybody else hear him?
No.
He's like really faint.
Yeah, I thought so. You're too far away from the mic.
No.
Yeah, I can't hear you, man. You got to look into that. All right,
Larson, just type in the chat.
Say again. Oh,
Can't you just type in the chat?
It'll be too hard though to go back and forth in the chat.
Yeah.
Meta, it's your turn. Let's try this one here. Do you know what trig ratio I'm going to be using for this one here?
No.
No? Do you remember your acronym for right angle trig?
No.
You don't remember it?
Is it like
Yeah.
tan over hypotenuse and
Okay. You're saying
Yeah,
them wrong. Let's do it. Sa, ka, koa. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Does that ring a bell now?
yeah,
Okay, so this one here, this would be what? Opposite over
hypotenuse.
hypotenuse. So which one is it going to be? Which trig ratio?
Toa.
Toa? No, that's O and A. This is O and H.
Oh yeah, I mean sine.
Sine. So it's going to be sine what? Sine 60 degrees equals?
0.866.
No, you're not going to write it like that. Hold on. All right,
Okay.
wait. I understand. Hold on. Is anybody else struggling with this? The actual triangle? Should I go back and actually do the triangles? Like just basic questions. Like, wait, just so you guys can see this. You got to say it now, like that one there. Should we actually do this question just to remember how to solve triangles again?
Yeah.
Yeah? All right, let's do it. So, let's start with this. Meta, you're okay to continue with this one first?
All right.
Sokotoa. Okay, the angles here. Now that would be opposite, and this would be classified as my adjacent. Opposite the right angle is always the H. Okay?
Okay.
So that's my adjacent. All right, which one has O and A here?
Opposite like Toa.
Toa, so that becomes tan, so question one. Tan what? What's the angle?
32.
32 must equal to opposite, which is
Hypotenuse.
H,
Oh,
H,
Okay.
over adjacent, which is
20.
And then how do I get rid of this division of 20?
Multiply it.
Multiply it. So it becomes H equals 20 times tan, 32 degrees. And you just plug that into your calculator. You can't get that into exact. And that just becomes 12.5. Does that make sense?
Mm-hmm.
All right, next, we'll do the next one. Natalia T. Let's do the next one together. You ready, Natalia? Okay.
Yeah.
So this is 47 degrees. Sorry. Julia observes a car approaching, blah, 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 30-meter cliff. There it is. The angle of depression is 47. Of the car at that instance is 47. And how far is he from the base of the cliff? The diagram's given to you. If this bit's 47, what do you know about this bit as well?
That it's 47
Yes, do you remember why?
because they're on the Z.
Yes, alternate angles, correct. Z, alternate angles. So that's 47, and then what are you going to use for this one?
For which one?
This one here. What trig ratio are you going to use now? Sine, cos, or tan?
Is it opposite over adjacent?
It is opposite or adjacent, so which one? Do you remember? Toa, tan, 47 equals opposite over
Over D.
over D. And then what do you usually do if you got D in the bottom? You just swap these two around, right?
Yeah.
So D equals to 30 on tan 47.
Do I do that? Calculator?
You can, why not? What do you get?
27.9.
Yep, so we'll just go 28 degrees. Okay. I think we should be able to move on now, and then you guys can look through this, have your homework. It's just basic stuff that you've been doing before. Now, let's get to this. Natalia, this question here. Sine 60 equals opposite over hypotenuse. What would you write? X over?
Oh, sorry.
X over?
Over 8.
Yep. And then what do you do with the division of 8? You have to multiply it. So you're going to have x equals 8 times sine 60.
Yep. Over.
Hold on. No, that's it. That's it. 8 times sine 60. But the thing is, before we were just plugging this whole thing into our calculator. But now it says find the exact value of this. That actually means this needs to be broken down a little bit more. So what we'll do, we get our calculator. You can't put the whole thing in. You only put the trig in. So you only put sine 60 into your calculator. What does it give you?
0.86.
Yeah, and then what do you do with that? You square it.
Yep.
And then you get 3 over 4. And then you mentally square root it.
And then it'll be 3 square root. 2. Root 3 over 2. Sorry.
Over 2. That's it. That's fine. Root 3 over 2. And then what's 8 divided by 2? Just becomes 4 square root 3.
Yeah.
Good job. You want to double check it? Plug in this whole thing into your calculator. 8 sine 60. Plug this thing in your calculator. 4 root 3. They should give you the same answer. Did that not make sense to anybody? Yeah, go ahead.
Sam, just wondering, so like, you know how the triangle's like at an angle, how do you identify what's the opposite and what's the adjacent?
Okay, good question. Always, so opposite the right angle is the hypotenuse.
Yeah.
Opposite the angle, literally, so there is only one side opposite the angle, which is that side there, would be opposite, and whatever is left will be classified as your adjacent.
All right.
So if you're looking at this one here, you know straight away this one here is h, that's your hypotenuse.
Yeah.
This, opposite this would have been this guy.
So that's opposite.
Right
All
there
right.
is adjacent.
Yeah, all right, I got you.
Yeah.
All right.
Well, now that you're here, you might as well do it.
All right.
Why not? So this one's what? Adjacent and hypotenuse?
Adjacent and so that's cos.
Cos. Cos what?
30
30 must equal to adjacent.
over 12. 12 over adjacent. Yeah, 12 over x. Yeah.
It's a over h, right?
Yeah.
12 over x. And then you just swap these two around. That's the trick for it. So x equals 12
over cos 30.
Okay, again, plug cos 30 into your calculator only.
Cos 30 will give me root 3 over 2.
Yes. Now, we've got to learn to simplify this, but I'm not sure if you guys are strong with your fractions over fractions yet. So the best
Is
thing
it 24 over root 3?
Yes, you got it, but let's just do it like this. 12 divided by division root 3 over 2. Right, so I split up the fraction to a division sign. Then this becomes 12 times 2 over root 3. Right, when you divide a fraction, you multiply and flip. And then 12 times 2, 24 on root 3. Which you can still rationalize, but we'll leave it for now. All right, let's go up. Any questions with that one?
No.
Anybody else? Any questions? Okay. You'll get this booklet with the word solutions, like I keep saying. All right, so that's the exact values done. What we need to do now is learn some new identities. There's not many for the advanced course, which is good. So we have a few new words that we've got to learn. We have sec theta now. We have cosec theta. And we have cot theta. So sec theta is 1 on cos theta. Cosec theta equals 1 on sine theta, and cot theta becomes 1 on tan theta. How will you remember this? It's not that hard. The third letter here must be the first letter here. Third letter, first letter. Third letter, T, first letter is T. Okay. Then we've got 3 more. Okay, so tan theta also equals to sine theta on cos theta. So tan theta can be written as sine over cos. Cot theta is 1 over tan, and if you've got it as sine over cos, that means that cot theta can also be written as cos theta on sine theta, if you needed that. Last one, sine squared theta plus cos squared theta equals to 1. Sine squared plus cos squared equals to 1. From that, we can get 2 other ones. If I needed just to make sine squared the subject, that becomes sine squared equals 1 minus cos squared. And if I wanted to make cos squared the subject, that becomes 1 minus, you bring the sine squared over. All right, I'll let you guys copy that. So sec becomes 1 on cos, cosec becomes 1 on sine, cot, there's 2 versions, 1 on tan and cos on sine. Tan is sine on cos, and then you've got sine squared plus cos squared, which equals to 1. Okay, no questions? Let's actually see how these work. So we're going to do all of these anyways. Super fun. Okay. Who's gonna go next? Nikki, your turn. You ready to do this first one?
Sure.
A. Yes?
Yep.
Cos theta times tan theta. Okay. Can I change anything for cos theta? Well, not really, right? You don't have anything that becomes cos theta. You agree?
Yep.
What do you know about tan theta though?
You can change it to sine theta over cos theta.
That's it. So tan theta becomes sine theta on cos theta, and then what would you do?
Just bring cos theta over.
Not over. This is only one side. You've only got one side. What would you do with these two?
Would you square it?
No, no. This is in the numerator. This is in the denominator. You would?
I'll cancel it Yeah, okay.
Cancel them out. And then you're left with,
Sine theta.
and that's it. You're done. That's A.
Wait, but what do you do with the negative? Because it's a minus? Oh, no, never mind, it's a times.
There's no minus. Yeah, these are times. These are dots. Okay, next. Where are we going for? Maybe I'll stop making a big screen just so I can see everybody. All right, Aiden, back to you. Cot theta times sin theta.
That would be cos theta over sine theta times sine theta.
And then what are you going to do?
You cross out the sine thetas.
What are you left with?
Cos theta.
Done. Good job. C. Anybody not getting what we're doing so far?
I'm not getting it, I will.
At all.
Nah, sort of, but I just gotta remember that thing.
You got to memorize all this.
Yeah. Wait, let
Yeah,
me
but
take a photo before you move.
As if you haven't written it down. You got to write this down.
Yeah, I got it.
Okay. Otherwise, like I said, you'll get this document and you'll get the whole recording anyways to go back over, but this needs to be memorized.
Yep.
Okay. Who's next? Chan.
Yeah.
1 minus sine squared.
Isn't that cos squared theta?
Right here. 1 minus sine squared is just cos squared. Simple. Good. D. Giovanni. D. Wait. I'll walk you through it. Okay. Now, what do you see that's common in both of these?
Squared.
No, other than the
Two.
squared. 2.
Yeah.
Well, this whole term, what have you been doing? You've been expanding, you've been solving, and?
Factorizing.
Correct. Factorizing. That's all you've been doing. So the whole idea of this is to factor out what number?
2.
2. Open bracket. What are you left with?
Sine squared theta plus cos squared theta.
What does sine squared theta plus cos squared theta become? Don't remember?
1.
1. Yeah. So what's your answer?
2 times 1.
Which becomes just 2.
Yeah.
Make sense?
Sort of.
E. We're going to do a lot of these with you guys. I know that. E. 1 plus cos theta, 1 minus cos theta. Effie, your turn. 1 plus cos, 1 minus cos. What do you think?
Okay,
what do
so
you-
it would be like 1 minus cos theta plus cos theta minus cos squared theta.
Yeah, but just look at this one more time. You said it right, but just look at it one more time. Does this ring a bell from something you've learned this term?
You're expanding the bracket.
Yes. Yeah, but specifically this type. Look at it. 1 plus cos, 1 minus cos. It's a special case of expanding. It's not coming to you?
No.
Okay, that's fine. Anybody can help us out with what I'm trying to say here?
Isn't it like difference of 2 squares?
Beautiful. It is a difference of 2 squares. Can you see that now?
Yeah.
1 plus cos. So you can expand. It's not a problem. It's just good to realize that that is a difference of 2 squares.
Mm-hmm.
So
That'll just be 1 minus cos squared theta.
beautiful. Which
Yeah,
equals
sine theta.
squared. Sine squared theta.
Oh, okay.
Good job. Fantastic. F. Sine cubed minus sine theta cos squared. All right. Oh, Heavy, why not? Let's do this one together as well. All right. What do you see that's common in both?
Sine.
Sine. Yep. So what are you going to take out then?
You're gonna take out sine theta.
And then what are you left with?
Sine squared plus cos squared theta.
All right. Giovanni, does that make sense what we've done there?
Yeah, bro.
Watch, Giovanni, look. We had this. Factorize. What do you take out?
The x.
X. What are you left with?
X squared plus y squared.
See? Exactly the same. What's common in both of these? Sine. What's left here? Sine squared plus cos squared. Exactly the same. Yep. And then what does sine squared plus cos squared become?
1.
So it's just sine theta times 1, which is sine theta. Everybody is good with that one? Okay. Before I do more proofs, I think what I might do for you guys is to do a few more of those. So, there's more proofs. Not what I needed. Let's go here. Let's go to yeah. No, it's too hard. There's a someone there. Trig functions. Okay, beautiful. Let's do some more. Pen page 10. Okay, who's next? Larson, is your mic fixed or go talk? No, I can't hear you very well. Very, very light. We got to fix that up. All right, Meta, you're next.
Alright.
Tan theta cos theta. Well, we just kind of did that, didn't we? So let's leave that one out. Tan theta cosec, so B. Tan theta times cosec. All right, what do you know about tan theta?
It's sine theta over cos theta.
What is cosec? Look at the third letter. S.
1 over sine theta.
And then what are you going to do now?
Cross out the sine theta.
And what's your final answer?
1 over cos theta.
Perfect. sec x cot x. All right, who's next? Natalia. Sec x, what is it going to be?
Is it 1 over cos?
You are right. And cot x, what are you going to pick? Are you going to pick 1 on tan? Or
No.
Cos on sine?
Cos and sine.
Why did you pick this one and not this one?
Because of the name.
Say it again.
They both have cos in them. Because
Yeah.
they both have cos.
Yeah, that's it. So you're not going to pick 1 on tan because they both have cos, so you might as well pick this one here. Cos x on sine x, that cancels out. What's your answer?
1 over sine x.
D, 1 minus sine squared. Well, 1 minus sine squared is just
Cos squared theta.
done. If it's theta, you write theta. If it's x, you write x. If it's alpha, you write alpha. Yeah?
Yeah.
E, square root. What's the square root of 1 minus cos squared? Well, what's 1 minus cos squared alpha equal to? That becomes sine squared. And then what can I do with the square root and the squared?
They cancel out.
The answer is just sine alpha. Yep. Any questions there? Okay. F. Okay. I didn't show you guys your cots and sec squares, so let's do those ones. There's your formulas right on the top. Okay. Let's do this. Okay, I need a different color because I can't see it myself. All right. Now, there are two other identities as well that you can derive from this. The other one becomes tan squared theta plus 1 becomes on cos becomes sec squared. And another one is on sine, so 1 plus cot squared becomes cosec squared. So 1 plus cot equals cosec. Tan squared theta plus 1 becomes sec squared theta. So a little bit of memorizing there as well. So I'm going to take a screenshot of that. We'll bring it down. All right, F. F just says, what is cot squared theta, or x, plus 1? Well, cot squared theta plus 1 is just cosec squared. So the answer for F is just cosec squared x. G. G says, what is 1 plus tan squared theta? Well, 1 plus tan squared theta is just sec squared theta. So the answer for G is just sec squared x. H. H says, what is sec squared minus 1? Okay. What would sec squared theta minus 1 equal to? Does anybody know the answer to that?
tan squared theta.
You are correct. Why? How'd you get that? Can you tell us?
Because if you move the 1 over to the other side, just
Over to the other side and becomes sec squared minus 1, which equals to tan squared. Great work. Okay, I says 5 cot squared theta plus 5. What are you going to do with the 5? You would probably factorize it out. And then again, what does cot squared theta plus 1 equal to? That just becomes cosec squared. So your answer is 5 cosec squared theta. J, K, and L. All right, let's try them again. J. J said 1 on cosec squared. 1 on cosec squared. All right, let me pick somebody. Yeah, Giovanni, let's do this one together.
I'll try.
All right, but look, so there's a little problem. Cosec squared. Cosec squared becomes 1 plus cot squared, right? There. Cosec squared becomes 1 plus cot squared.
Yeah.
You could put that in, but cot squared itself, I mean, cot is a fraction, isn't it? Cos over sine and stuff. So that still needs to be simplified a bit more if you were going to put in cosec squared. So that isn't the right one to put in. The one they're looking for is this one here. What does cosec theta equal to?
1 on sine theta.
So what would cosec squared theta also equal to? Cosec squared would equal to 1 on
Sine squared.
Yeah, that's the idea. If this was sec cubed theta, this would equal to 1 on
Cos squared theta.
Cubed, cos
cubed. Yeah.
Yeah. So what we're going to use this one here. Cosec squared is 1 on sine squared. So let's go down for a second. This one here equals 1 on, what did I say? Cosec squared becomes 1 on what?
Sine squared.
Sine squared x. And then you simplify that. So 1 divide 1 on sine squared. It becomes 1 times sine squared x on 1. Do you agree with what I've done there, Giovanni?
I'm just writing it down one second.
Yep, write it down. Anybody have any questions? And can you see how that is simplified compared to if I had subbed in cosec squared as 1 plus cot? It wouldn't have got you anywhere.
Yeah, it's making sense, sort of.
Yeah.
Look,
it's the first time for everybody, right? It's your first time. It's not. You're not meant to fully get it today, but by next week when you review the video and you go through all the notes, you're meant to pretty much understand how each one works and how they transform.
Sam, can you do J again, please?
Yep. So let's do it together, you and me then. Again, cosec squared. Cosec squared x becomes what? 1 on sine squared x.
Yeah.
And then what do you know with 1 over a fraction? Well, you can write 1 divided by that fraction, which would just be multiplying the reciprocal of the fraction. And then your 1's just cancel out, they're irrelevant, so it just becomes sine squared x.
Oh, okay.
Let's try K. Okay, K says sine squared times cosec squared. So Nikki, let's do this one together. Sine squared times cosec squared. Again, cosec squared theta, you wouldn't pick the 1 plus cot. It's not the right one. The reason being, if you place that as 1 plus cot, you've got a lot more math to do now to simplify it with sine squared. So Nikki, you there?
Yep.
So sine squared, you're not going to change. You're just going to leave that as sine squared theta times, what should you change this to? 1 over?
Sine theta.
Sine
Theta.
squared. Yeah, sine squared theta. And then what can you do with your squares?
Cancel.
What are you left with?
1.
And that's it. Easy. All right. The next one's easy. I think we'll do some proofs now. Let's have a look at some of these proofs. All right. Okay, Aiden, let's do the first one together. All right, we're trying to prove, so understand, we're trying to prove this time. We're not going to write both lines at the same time. What we're going to do is work on the left-hand side, get to a result that is hopefully the right-hand side.
Yeah.
All right, so left-hand side is square root of 1 minus cos squared.
Yeah.
What do you know?
You could put
Yeah,
sine squared theta.
correct. And then?
And then you take out the square root.
What do you mean by take it out?
Because the square and the square root cancel each other out.
Yeah, that's better. Cancel.
Yep.
So cancel the square and square root, and that becomes?
Sine squared.
Nope.
Sine squared theta. Sine theta.
Just
Sine theta.
yeah, just sine theta. That's exactly what you needed. Just sine theta, which equals to?
Right hand side.
Anybody have any questions with that one? So the ones we were doing before, there was no right-hand side, so we didn't know where we were going, and that's why you had to like take educated guesses with how you would want to change these. But now that you have the answer, you kind of know the direction you're going to move towards. You'll know, oh yeah, I've got to change that to sine, and then the squares and square root cancel out, and voila. Okay, B. Meta, let's do B together. Sec squared to the left-hand side equals, all right, sec squared theta. What are you going to change sec squared theta to? 1 on? The third letter.
Theta. Cos squared theta.
Good job. Cos squared theta times, and then what does 1 minus cos squared theta become?
Sine squared theta.
And then when you multiply fractions, you just go straight across, right? So that simplifies to this, which becomes what? Sine over cos.
Tan squared theta.
That's it. That actually becomes your right-hand side. Remember I told you the answers are going to be given to you. So it's nice to use them. Sine on cos is tan. Sine squared on cos squared becomes tan squared theta. That's it. Any questions for that one? Anybody? Making sense. That's good. C. So let's just do that. C. Tan theta times square root of 1 minus sine squared. Nikki, let's do this one together. Tan theta times square root 1 minus sine squared. Okay, what do you know about tan squared?
It would be sine theta over cos theta.
Tan theta is, no, not squared. There's no squared there. Look, Nikki, look at this. There was a squared here, there was a squared here, right? So that's why I was able to write tan squared. If it's just tan theta, what would you write?
Sine theta over cos theta.
Only. Good job, times. And then square root.
Cos squared theta.
Already getting used to it, that's good. And then what do you do with your squared and your square root?
And the squared out.
And then if you can see this is going to be on the top, right? Cos theta. This is on the bottom. What are you going to do with cos and the cos theta?
Yeah, you cancel them out.
And then what are you left with?
Sine theta.
Exactly what you needed. Don't lose track of what you're trying to prove.
Yep.
We can do things in 1 or 2 lines. Super easy. Good job.
Thanks.
D. D, I think that
Sam,
one.
how are you getting, Sam?
Sorry?
How are you getting rid of the square root again?
Square root and cos squared. So like this. Root x squared. What are you allowed to do with the squared?
Cancel them. Okay.
Yeah.
Alright.
They're just opposite. So it just becomes x. Same thing with this one. Cos squared. Yep. So the squared and the, yeah. All right. Chan, you're going to do D.
All right.
All right. Cot theta.
Would cot equal 1 over tan theta?
You are right, but you chose the wrong one. Now, how would you know? The way you know is looking at your right-hand side here, right?
Yeah.
What would these two become in terms of?
1 over sine times 1 over cos.
So they're in terms of sines and causes. So do you really want to just leave these in terms of tans?
No. So would it equal cos over sine?
Yeah, that's the logic. Plus?
Tan theta.
No, tan is?
Sine over cos theta.
Yeah. You don't want to leave it as tans because there is no tans on the right-hand side.
Yeah.
It's sines and causes here. Okay. Now, we use our algebraic fraction skills.
No.
What's my common denominator?
Sine and cos. Sine theta, cos theta.
And then just cross multiply?
Cos squared theta plus sine squared theta.
What does cos squared plus sine squared theta equal to?
1.
And is this the result you wanted? 1 on sine and 1 on cos?
Yes.
1 on sine, 1 on cos. 1 on sine is cosec.
And 1 on, yeah.
And 1 on cos is? Sec.
Sec.
Because right hand side. So I'll let you guys look at that for a minute.
Sam.
Mm-hmm.
I didn't understand the last part. 1 over sine theta and cos theta.
So what is cosec theta?
1 over sine.
Yep.
Oh, okay.
What is sec theta? What is sec theta? 1 over?
1 over cos.
Yeah, so this is actually this, yeah. Anybody else before we move on? E. Okay, let's try E. E is sec theta minus sec theta sine squared. Natalia T. Let's try this. Sec. E, oh, sorry. Left hand side. Left hand side equals sec theta minus sec theta. So sec theta minus sec theta sine squared. All right, what are you going to do?
You change the sec theta to 1 over cos theta.
No, not yet. Now,
Oh,
The
you
re-
expand. Oh.
the reason why I wouldn't convert it straight away is because you would have to write it twice, but there's a better technique. When you see two things that are the same, what are you allowed to do?
Oh, you can just cancel them out.
No, not cancel. Cancel only if it's numerator and denominator.
Oh, you're allowed to square.
No,
I don't know.
factorize. We're going to factorize this out. And then what am I left with?
1 minus sine squared theta.
Now, look, I'm only going to change sec theta once. What does sec theta become?
1 over cos.
Instead of here, I had to write 1 over cos here and 1 over cos here. And then it would have just been wrong. So factorize first, and then, what's this? What does 1 minus sine squared theta become?
Cos squared theta.
And then what are you allowed to do with your squared and your, well,
Out.
I'll cross it out, aren't you? We want cos theta. Does that all make sense?
Yeah.
So factorize first. If you can, you've got to factorize first. Then 1 minus sine squared becomes cos squared. The squared and the 1 power at the bottom cancels out. You're just left with a cos theta on the top. I'll do G. F isn't too bad. I'll do G. And then we'll do some of those other questions. G. 3 cos theta plus 5. Squared, and then what? Plus 5 cos minus 3 sine. And hopefully when we do this, it becomes 34. All right, Natalia, V. Let's do this. Left hand. Yep.
So, yeah.
What are you going to do when you see this? It's squared and squared. What is your gut instinct tell you to do first?
You have to expand it.
Expand. So 3 cos squared theta, when you expand, it becomes 9
squared
cos squared.
theta.
Yep.
Yep, plus 30
2.
sine.
30, right? 3 times
Yep.
5 is 15, times 2 is 30. Cos theta.
Yep.
Yep. Plus
Okay, yeah.
5 squared.
Plus sine squared. So I'm like lost.
Does that all make sense?
Oh, okay. Yeah, sorry, I got it.
First one squared, 2 times the inside. There it is. Last one squared. There it is.
Yeah.
Plus, do it again. Let's go with this one here. What are you going to write? Whoops. No equals. So plus, we've still got to expand this one. So what's this one squared?
Wouldn't it be 81?
5. Just 5 squared.
Wait, I'm confused.
So this first one here, this first bracket, that's the answer for it. That's the first one.
Okay, yeah.
Plus
And then after this.
Second bracket.
25. Yep, so 25
Yep.
cos squared theta, yep, minus 30 cos theta sine theta,
Yep.
plus
Plus.
9 squared.
Beautiful.
Not,
All right.
so you find sine, yeah.
Now, what happens with your 30 cos sine theta minus 30 cos sine theta? That's plus 30 minus 30. It disappears,
So-
doesn't it?
Yeah.
And then what are you left with here? 9 cos squared plus 25 cos squared.
So 34 cos squared theta
Beautiful.
plus 34 sine squared theta.
Yep. And then what do you see? 34, 34. What are you going to do?
You factor out. So it'll be 34 and then in brackets cos squared theta plus sine squared theta
And what do you know this cos squared plus sine squared becomes?
equals 1.
Equals 1. So my answer is just equals to?
30.
And that's exactly what we wanted.
Yeah.
Good job. I'll let everyone copy that. Anybody have any questions for us? Giovanni, you understand the expansion of what I've done there?
Yeah, but it's just a bit of a headache.
Say it again.
I get it, but it's a bit of a headache.
Sam, how did you get 34?
Yes, I can hear you now. 34. From which line though? Are you okay with? Wait, are you okay with the first line?
Yeah.
Are you okay with the second line?
No.
No. Okay. 9 cos squared plus 25 cos squared. What's 9 plus 25?
Okay, plus 9. Yeah.
And same thing with this one. 25 plus 9. 34. So you're just simplifying.
Okay.
Yeah. So you guys, you probably have it in one line. I can't fit it on here in one line.
Yeah.
Good. Anybody else? Any questions? No? Okay. Let's move to these questions. Okay, prove. Prove the first one. Left-hand side. I'm just going to use thetas for everything. I just like them more than x's and alphas. I think you guys won't mind either, so let's just use that. Left-hand side becomes cos squared theta minus 1. We need to prove that it becomes negative of sine squared. All right, Aiden, tell me what you want to do.
So
you know 1 minus cos squared is sine squared, but that doesn't say 1 minus. That says cos squared minus 1. So what are you going to
do? Can you change the cos squared theta to 1 minus sine squared?
Hey, why not? Change your cos squared to 1 minus sine squared. I like that. And then you still got a minus 1?
Yeah.
And then what happens?
The 1's cancel out.
What are you left with?
Negative sine squared theta.
Fantastic work. I'll be honest, I didn't see it like that. The way I saw it was taking out a negative, so mine would look like this. So there's a lot of ways for each question. Each question has 3 different ways of doing it. So just so you're aware. But here we go. My way was going to be taking out a negative from this. And then I'm left with this. Can you see that, Aiden? If I factorize a negative out from these two, I'll have negative and then 1 minus cos squared.
Yeah.
And then what does 1 minus cos squared become?
Sine squared theta.
So that would have been my technique. Your one worked perfectly. Why not? It's the same thing. Good job. Okay. B, let's try Giovanni.
Yeah.
Let me know when you're ready. You ready for B?
Sure.
Okay. Sec theta.
Would
What do you
be
guys
1 over cos theta.
see? You're already starting to get used to it. Plus tan theta.
Sine theta over cos theta.
And then they're over cos, if they're the same denominator, then you just leave it. What does the top become? 1 plus
1 plus sine theta
over
cos theta.
which equals,
Um,
look up here.
oh,
Equals
yeah.
right hand side.
Yeah.
Done. Make sense? That was easy.
Yeah.
Wasn't it? All right, number 3. C, we need to prove 3 plus 3 tan. 3 plus 3 tan squared theta equals 3 on 1 minus sine squared. 3 on 1 minus sine squared. Okay, let's try to do that. Chan, left hand side.
Would you take the 3 out, so like you make it the common factor, so 3 bracket tan or 1 plus tan squared?
You must, correct?
And then we know isn't tan okay equals 3 is it so 3 times sec squared theta?
Correct. 1 plus tan squared is equal to sec squared. Okay. That's good, but it's still not this.
Yeah, and we know sec equals 1 over cos squared theta.
Come on, you're there. You're there. Look what you need. Look what you
1
have.
minus sine. And doesn't cos squared theta equal 1 minus sine squared theta?
Easy. Keep that in mind all the time. See how you got stuck?
Yeah.
What you're trying to do, it's a poor technique. What you're trying to do, you're trying to just work on the left-hand side and hope that you can keep working it out until you get to somewhere. It's not the right technique. What you're meant to do is work on your left-hand side, keep an eye on your right-hand side, and it tells you the answers of what you're trying to do. So if I was to see 1 minus sine squared, I'm already thinking that's cos squared. So when I see cos squared here, I already know I've got it. It's done.
All right.
Yeah. So keep an eye on your right-hand side.
All
Good
right.
job. D. D sec squared minus tan squared. Sec squared minus tan squared, and we want it to become what? Cosec squared minus cot? Fair enough. Okay. Who shall we pick for this one? Nikki, let's try this one together. Left hand side. Okay, Nikki, are you there?
Yep.
Am I going to change sec squared to 1 on cos squared, and same thing with tan? Or am I going to replace sec squared I'm trying to do a really quick way of doing this now for you guys. And look, sec squared is 1. Yeah, that's what I would have done. Okay, look, like I was saying, would you replace this for 1 on cos and then this one for sine on cos? You could. There's just so many ways of doing this. Look, there's I've already thought of about 4 different ways of solving this question, right? And every way you would have done would have worked. It wouldn't have been a problem. It's just a matter of trying it. I can tell you the most efficient way. The most efficient way is for me to change sec squared on the left-hand side to tan squares. So what does sec squared theta equal to? Do you remember, Nikki, in terms of tan squares?
Tan squared theta plus 1.
Yeah, so I'm going to change just the left-hand side to tan squared theta plus 1. Now, I'm not going to go change this to sec squared because it'll just get me back to the original question. I'm just going to leave this guy as it is. Now, what happens? What's your left-hand side equal to? I only change this one. What happens?
Do you take them out? Like
yeah. Well, no, you're not going to factorize because they're not all 3 of them. You're just going to cancel these 2, right? You guys are missing the fact that this is just the same as this guy and it's a minus, so you can cancel them out. So what are you left with your left-hand side?
1.
1. Now, that's great, but that's not the right-hand side. So for this technique, we're also going to work on our right-hand side. And what are we hoping that it becomes?
Cosec squared theta minus cot squared theta.
Yeah, but we want the right-hand side.
Oh, to equal to the left-hand side.
Yeah, so we want it to become what number? We want it to become 1. So what does cosec squared equal to? Cosec squared from the formula above was cot squared theta plus 1.
Yeah.
And then what happens in this line? Cot squared theta minus cot squared theta.
Cancel them out.
What are you left with?
1.
Therefore, what?
Left-hand side equals to right-hand side.
So they're both equal to 1. Now, if you had changed these to sines and causes, like I said, it would have worked out. It would have just taken you maybe 6 or 7 extra lines.
Can you do it again?
Yep. So, last, do you know sec squared is tan squared plus 1? Have you memorized that now? Yep, good. And you memorized that cosec squared is also cot squared theta plus 1?
Yeah.
Good. Okay, so left-hand side. Left-hand side is tan squared plus 1, and then I left this guy, minus tan squared. This cancels out with this. You're left with 1. Same thing on your right-hand side. Cot squared plus 1 minus cot squared. Cot squares cancel out. You're left with 1. Because 1 equals to 1, therefore, your left-hand side must equal to your right-hand side. Yeah. Make sense?
Yeah, yeah.
Okay. E. Don't need to do E. That's just going to be too silly for us to do. That one seems easy. This one. This one. Yeah, I'm definitely going to do F. I think F is really good to do. F. F cot theta plus 2 sec. And we're trying to get it to become, what is it? 1 minus sine squared plus 2 sine theta. Okay. Left hand side. Who wants to do this one with me? Nobody? All right. Then here we go.
Sam, could you write like the whole question out, just so, like what does that equal? Yeah.
1 minus sine squared plus 2 sine. 1. Okay. So left hand side. Left hand side is cot. I'm going to choose cot for cos over sine plus 2 sec theta. Sec theta is on cos theta, right? Anybody have any issues there before I move on? No? All good? Next line. Common denominator. Cross multiply. I think we're done. That was easier than I thought. Cos squared plus 2 sine. Look, the denominator is there. 2 sine theta, 2 sine theta. This one just says 1 minus sine squared. Well, you know that cos squared is.
Sam, doesn't cot theta become 1 over tan theta?
Yes, but there's 2 of them. So there's 1 over tan and there's cos over sine.
Okay.
Look. Cot theta, 1 over tan and cos over sine.
Does it work for both?
It will not work for tan because your right hand side is all what? Sines and coses. Yeah?
Yeah.
So therefore you're going to pick sine and cos. If the right hand side said tan here, I would have not chosen sines and coses for cot.
Okay.
Any questions? Anybody else? Okay. Let's look at exam questions now. Right, as soon as we finish off a concept, you start feeling good about it, you understand what you're doing, you jump straight to exams. That's how this works. Exams.
Sam,
Yeah,
did you email us those exams though?
you have a lot of them on THSC. When you finish those ones off,
Doing right now.
sorry?
Are the ones that we're doing right now on THSC as well?
Yeah, like look what I'm doing. So, I've opened up an exam paper, right? And you just scroll through. You're like, all right, algebra and surds, yep, you just did that. Equations, yep, just did that. Geometry, no, you haven't done that. Functions, yes, you've done that, so you can do those questions. Trig, that looks relevant for you, but we haven't done these triangles yet. There it is. Show. We haven't done solving yet, so you guys can only do the solving bit. I mean the showing bit so far. Do you get what I mean by doing that? So just open up a paper and start doing a question. Yep. All right, let's do this one. What does tan theta become? Sine on cos plus. What does cot theta become? Common denominator.
Cos on sine?
Yep, cos on sine. And then common denominator becomes cos theta, sine theta. That becomes sine squared plus cos squared. What's sine squared plus cos squared? 1. 1 over cos theta sine theta, which equals to the right hand side. We literally have done that one, right? See? You don't need 1,000 textbook questions. Once you feel comfortable, you just jump straight to exams. Close. Next. Geometry, there's some trig, but not what we've just been doing, solving, simplifying. No, nothing in there. And if there's no trig, then there's no point of looking through it. Trig, that's range. Discontinuous function, that's all about functions. Final exam. There we go. Anybody have any questions on how to look, like identify? You'll know the very first section, look at that, got nothing to do with trig, quadratics, alpha, beta, got nothing to do with discriminant. Oh, there you go, trig. So we agree we can identify them. They're not too hard to realize, recognize. We should be able to do both of these. So I'll take a photo of them. Okay. Aiden, let's do the first one.
Yeah.
Proof cos theta times sec theta minus sine squared becomes cos squared. 2 marks. Let's see if you can get it. Go. I'm not going to say much. You just tell me to do it, I'll write it.
So cos theta can equal
I'll help you so you don't get stuck. It's just cos, you can't do anything to cos theta.
then sec theta becomes 1 over cos theta. And then minus sine squared theta equals 1 minus cos squared theta.
No, what? Yeah, but you don't need to do that. Oh,
Okay.
You didn't need to, but because you said it. What? Minus 1 minus. Okay, yes, next line.
Then can you cancel out the cos thetas?
What are you left with?
1 minus 1 minus 1 minus 1 cos squared theta.
Wrong. 1 minus 1
Plus cos squared theta.
Make sense?
Yeah.
Good job. You got yourself 2 marks. B. Natalia V. Please, because you missed out some of these exact values, so I would like you to do it with me. You there?
Yeah.
Yeah, right. Let's
Yeah, sorry.
find the exact value of this expression. Also worth 2 marks. All right. So you can't plug the whole thing into your calculator, right? We'll do it individually.
Yeah.
So tan 150.
It's negative 0.57 and you square it.
Yep. So what does it become? What's the answer?
333.
And then press SD.
1 over 3.
1 over root 3.
Root 3, sorry.
Because you're not allowed to square it, right? That's okay. Cos 60.
Yeah.
Straight away, the answer you see.
It will be 0.5 and then so.
You don't need to square it. No. So if it's half, the answer is a half.
Oh, okay, so half, yeah.
The only ones where square rooting and squaring and everything are the ones that where you get your first answer is really bad, like this. 0.577 goes on. Yeah. Over. Sine 30.
It's half as well.
Half as well. Okay.
Yeah.
Next line. That's in the numerator, so that becomes -1 on 2 root 3 divided by a half. Do you agree with that, what I've done there?
Yeah.
So numerator divided by denominator. All right, what's your next line?
Would it be root?
What do you do?
Oh, you flip it and you times it. Yeah.
And then what do you do now with the 2 and the 2?
Do they cancel out?
They do, because one's on the top, one's on the bottom.
And then it'll just be -1 over root 3.
Any questions from anyone? Were we all able to follow that? So you guys can see that it's still, I guess, algebra that's going to let you down, not trig. The trig bit is easy to do. It's this bit here, the algebraic expansions, factorization, so on. That's really important. Okay, let's look at some more.
Sam, can we do another question like that?
Yep. I think we opened this one before.
Hey Sam.
Yeah.
I'm just gonna head out to the toilet. Alright.
Cos 225 sine 60. Cos 225. Okay. Giovanni.
Yeah.
Cos 225. What does it become?
Negative 0.707.
So what's the answer I'm looking for?
0.5.
Nope.
1 over root 2.
There we go. -1 over root 2. Yes?
Yeah.
You sure? Are you 100% confident that you can get that to that straight away?
Not straight away, but...
Okay. 10:30. Try that one now. Don't say anything until your final answer. 10:30.
1 over root 3.
Correct. Sine 60.
Root 3 on 2.
Done. Now you're there. All right. Everybody is with me up to this stage? All right. Giovanni, next line. We'll do just the numerator first, which is -1 on root 6. Divide root 3 on 2. What are you going to do now?
Kick times flip. So 3 on root 2.
2 on root 3.
Oh, yeah.
-2 on root.
18.
And then because we know square root of 18, you can simplify it to Root 9 is 3, root 2. Okay?
Yep.
Should we do another one? Or are you alright with that now?
One more would be better.
One more? Let's do one more.
Yeah.
No problem. Okay. I might change it up a little bit. I might write it now as cos 45 minus tan 60 squared. Okay. Do you want to try it, Giovanni, or you want to try it, or you want me to do it?
I'll let you do it.
Meda, do you want to try this one with me? Does anyone want to try it?
Oh, sure.
Yeah, all right. What would you do when you see this squared? What's your first thing to do?
Is it cos squared 45
Correct. Yep, next.
minus 10 squared 60?
Nope. Come on. Expanding a squared. 2 terms. You got to do it properly. What you said that was not true. Anybody can help her out?
Is it a perfect square?
Yes. So can you tell us what to do?
You plus them and times them by 2.
Yep. So what's the next thing? What are you going to write here?
2 times the middle.
2 times the middle. Middle, does that make sense?
Yeah.
Yeah, you can't forget that. And you said minus 10 squared. Always got to be plus. Plus 10 squared 60.
Okay.
All right. Okay, cos 45. Plug it into your calculator. And then square it. Well, that is the answer. So that just becomes half. You
Yeah.
don't need to square root it. Same thing with this one. Do tan 60. And then just square it. What does that one become?
3.
Just 3. Now we've got the inside to work with. Minus 2 times. Work out what cos 45 and tan 60 is for me now. Cos 45.
It's half.
Nope.
Negative 1 over 2.
Nope. Let's try it again. So half was right. And then you're meant to square root that. So it becomes 1 on.
Square root 2.
Yep.
Oh, okay.
And do the same thing for tan 60.
Um, 3.
So your answer is?
Square root 3.
Yeah, root 3, square root 3. Perfect. Next one. A half plus 3 is 3.5. So 3.5. Might not plus. Minus 2 root 3 on root 2. 3.5, we just write it as 7 over 2. And because we're here, I like to rationalize this root 2 as well this time. Minus 2 root 6 on 2. 2 and 2 cancel. The answer is 7 on 2 minus root 6, an exact value. Exact. Giovanni, did that all make sense this time?
Yeah.
Then the perfect square. Plug it into a calculator. That one you can plug into your calculator. This one's you've got to plug in and then mentally square root them, and then just do a bit of algebra.
The only thing I don't know how to do is when you change the square root.
This bit. When you change the square, what, you mean this bit here, the rationalizing?
Oh yeah, rationalizing.
So this bit, yeah. So this bit, it's really easy. Just times the top and bottom by the denominator here. So if it's root 2, you just times it by root 2. If it was 3 root 2, you still times it by root 2 and root 2.
Sam,
Yep.
you know for the part at the first line where it's -2 cos 45,
Yes.
how do you do that part? Do you have to like
Okay, ready?
the middle one?
How do I expand this?
A minus B. Is it like differences of 2 squared?
It's not, it's a perfect square.
A
So this
squared.
A squared
Minus 2AB
plus.
plus B squared.
So that's exactly
okay.
what I've done. First one squared minus 2 times AB plus B squared.
Okay.
Okay. Let's do. 10, are you back yet? Still not back. No, 10. Okay. Can you guys go ahead and do these, please? We'll start with question 16. So that's a simple SOHCAHTOA question. Find the length of side BC. X. Opposite over hypotenuse. I'll leave that with you. Please do that. If you don't know where to start, just let me know. I'll start you off. Everybody know where to start with this one? So you would have done what? Opposite over hypotenuse, which is sine.
Sam, where are the questions?
Right here.
I can't see it. My screen's just grey. It just says Saturday 12 to 2.
That's strange. Is that for everybody?
No, I can see it.
Okay.
Yeah, I can see yours.
Alright. Chan. Maybe I'm gonna do it again. Option. What about now?
Oh yeah, I can see it now.
Alright. Number 16. Sine 17 is equal to opposite over hypotenuse. So x equals to 3.25 on sine 17. The question does say 2 decimal places. You would lose 1 mark if you didn't write it in 2 decimal places. So my answer is 11.12. Everybody's okay with that? Anybody have any questions? Sorry?
I got the same.
Great, perfect. Okay, then I'll move on. Number 18. 1 mark each. Find the exact ratio of sine, sec, cosec. Let's go. Let's do sine 315. All right, I've got my answer. When someone has an answer, let me know what your answer is.
Is it -1 root 2?
You are correct. -1 on root 2. Sec, there is no sec on your calculator. So what must you do with sec?
You find out what sec is, isn't it 1 over cos?
Correct. So 1 over cos 225. So you're going to work out what cos is.
Is it -2? Or
Cos 225 is -1 on root 2. 1 over -1 on root 2, you're going to just flip it and multiply, which becomes negative root 2. All right, you guys. Last one. Cosec 240. Cosec 240. Okay.
It would
Cosec
be 1 over sine.
1 over sine 240. Plug 240 sine 240 in your calculator. And then you should get -2 over root 3. Anybody still struggling how to go from here to here? No, we get it.
Does the one just cancel out and just flip them?
Pretty much, yeah. Or you're going to do this, right? 1 times 2 on negative root 3, right? That's what you're doing, because when you divide, you're going to flip this. So, yeah, the 1 just cancels out and becomes 2 on negative root 3 or -2 on root 3. Yeah, pretty much. Okay. Good job. I just realized something rather unique, actually. So look at this last question here that they've given in this particular exam, right? And look at the questions, show that BP equals 3, whatever. Maybe the angles are a little bit different, but look at my question that I've got. Looks bloody similar, doesn't it? How fun is that? So if you do all my questions, you generally are okay. I promise you. They even use the same letters. They even use the same letters. Mine's a B on the top, theirs is a D on the top. Anyways. Alright. So exams. I can't keep emphasizing exams. Discard that. Save this. A advanced. Save. Okay, so I'm going to